So this branch of mathematics I think is really cool. And I know you're laughing right now because I always say, oh, I love this, it's so cool, it's so cool. But trigonometry is one of my, I'm going to laugh again, it's one of my favorite units. It's a really neat thing because what you're doing is you're connecting the side lengths of right triangles and the measures of angles. And I mean, they're two completely different things. I'd hope by this point of the year in geometry you realize that side measures are one thing and angle measures are something else. So, going to move on a little bit. We're going to talk about some trigonometry because here's where trig kind of started. So realize that mathematicians kind of noticed that when the ratio of the shorter leg to the longer leg of a right triangle was a certain value, the angle was very close to another value. Like in this one here, you can see like when this side is 3 and that side is 5, the angle is about 31 degrees. So you see these similar triangles? If I multiply those sides by 3, I get 9 and 15. But we know that the similar triangles keep the angle measures the same. So here's what mathematicians realized, that if they could get the sides in a 3:5 ratio, that 3:5 ratio resulted in a 31-degree angle. So you're thinking, well, why know that? Well, now we can figure out how high a tree is, because we all want to know how high trees are, right? So the idea is that I have a 31-degree angle here. So therefore, I know that this side is in my ratio of 3 and that side's my ratio of 5. So if I call this side h for a minute, I can say maybe that the ratio of 3 to 5 is equal to h over 36. And when I go and I solve this, I cross multiply, and I'm going to get h to be 21.6, the height of this tree. So that's pretty neat. But then there was a big problem. The big problem is there's so many different ratios. I mean, if the angle is like 37 degrees, something different. 46 degrees, something different. Crazy. There's too many ratios to remember. So the branch of mathematics called trigonometry was related. And this ratio that we just used, the leg that's opposite to the leg adjacent to the angle, we call that the tangent of the angle. So the tangent of an angle is equal to the opposite side divided by the adjacent side, whatever that ratio is. And don't worry about writing that down right now because I'm going to get to a whole bunch of these ratios in a second. This is the page that you want. So we have a right triangle, and let's call it triangle ABC. We'll make angle C the 90-degree angle. There's 3 different ratios that we use. So the first one is called sine. Okay, S-I-N-E. It's pronounced sine. It's not pronounced sin. But we usually just say sine of angle A. And the sine of angle A is the length of the opposite side. So based on angle A here, this is my opposite side to the length of the hypotenuse. So the sine is opposite over hypotenuse. The next one we call cosine. And the cosine is the adjacent side to the hypotenuse. That's our ratio for cosine, adjacent over hypotenuse. And finally, like we saw before with the tree height, the tangent. So now maybe you've seen these buttons on the calculator before, the sine, cosine, and tangent buttons. And tangent, as we saw, was opposite over adjacent. And there's a great way to remember this, a fantastic way. A lot of students like to remember SOHCAHTOA. And they remember that because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's how they kind of remember those things. So let's get going and do some trig. We're going to go back to the tree problem for a minute. So we're going to write this equation. If we look at this triangle, we know that this angle here is a 31-degree angle. We know that the adjacent side is 36, and we're looking for the opposite side, which is the height. So if we think of this SOHCAHTOA thing, we realize that we have the opposite side and the adjacent side, so we're using tangent. And that's where we'll write that equation. Tangent 31 equals h over 36. Now, when we solve this, I don't like to go and just type tan 31 in the calculator. You know from before, we let the calculator do all the work. So one thing I like to do is I like to multiply here because I like to say when h is in the sky, when the variable's in the sky, you got to multiply. So I'm going to multiply those two together. So my value of h is going to be 36 times the tangent of 31. Now, if you've got your phone calculator, what you want to type in first is you want to type in 36, then you want to type in the multiplication symbol, and then you want to type 31 and then tan. That's what you got to do when you're using your phone. And then press equals. So 36 times, you type in the degree measured, then press the tangent button. 36 tan 31. And I think when you do this, you're going to find out that it equals about 21.6 also. I think it was like 21.63 and a bunch of decimals. So we'll say the height is 21.6 meters, which was the same answer we got doing the ratio before. So that makes us feel pretty good. All right, time to go and play. Are you ready? So I have this triangle here. We want to use trigonometry to find the values of A and B. We're going to first start by finding A. See if you can write an equation for angle A. Okay, so let's see. If I'm writing the equation for angle A, I'm going to start at my 70-degree angle. And then based on the 70-degree angle, the opposite side is 13, and the hypotenuse is A. So let's see if I can write an equation using opposite and hypotenuse. If I remember, I have this SOHCAHTOA thing. So I have my opposite and my hypotenuse, or I know the opposite, I'm looking for the hypotenuse. So this is going to be sine. So the correct equation is going to be the sine of the angle equals the opposite side over the hypotenuse. Now when we solve this equation, remember before we said when the variable's in the sky, you got to multiply. Well, what I like to do is, since the variable's in the bottom, I like to do what's called slip, slide, divide. So I'm going to slip the A out, and I'm going to take the sine 70 and slide it in there, and that's what I'm going to type into my calculator. So on your phone, you're typing 13, you're doing divided by, you're doing 70, and then you're pressing your sine button, and then you're pressing equals. So when you type all that in, you should get that A is about 13.83. So we're going to the nearest tenth, it says here. So let's say it's 13.8. That's going to be our value for A. Can you do the same thing for B? Give it a shot. So if we're finding B, notice that B is the adjacent side. 13 is opposite. So that's going to be tangent. So if we write an equation now, the tangent of the angle, tangent of 70, is equal to my opposite side divided by B. Let's see if you can solve that equation for B and round it to the nearest tenth. So we go B equals slip, slide, divide because the variable's in the bottom. We get 13 over tan 70. So when you go to your phone, 13 divided by 70, press the tan button, press equals. You should get that B equals about 4.73 in a bunch. So let's say that B is 4.7 rounded to the nearest tenth. Cool stuff. Let's keep rocking. So what we're going to do now is we're going to work the other way. We're going to be given two sides, and we're going to find the measure of the angle. Same idea. I still want to go back, and I still want to think about that thing, SOHCAHTOA. SOHCAH. Why am I writing so fat? I don't know. Let me see if I can change it. I'm doing this on an iPad now. So it's kind of a little bit different for me, but we'll figure it out. Alrighty, so let's see if that does anything different. I have no idea if it will. But anyway, I'm looking for the measure of angle B. Oh, we're back, good. So based on angle B, 8 is the adjacent side. 15 is the hypotenuse. So if I got adjacent and hypotenuse, I'm using cosine. So the cosine of angle B is going to be 8/15. Now this is kind of weird because how do you do the opposite or the inverse of cosine? Well, you do just that. What you're going to do is you're going to take the inverse of cosine. So this is the equation we're going to end up with. And I know you're saying, wow, where the heck did that equation come from? That is definitely worth talking about. So let me erase that for a minute and talk about how to get that for a second. Alrighty. So what I want to do is I want to do the inverse on both sides, because that's what we always do. Like if you're solving 3x equals 12, you're saying multiply by 3, so the inverse is divide by 3. So we're going to do the same exact thing there. We're going to do the inverse of cosine. Well, what is the inverse of cosine? It's just that. It's called the inverse of cosine. And then we write it this way. We write it as cosine to the -1. That -1 exponent implies that we're doing the inverse of a function. So if I do the inverse on this side, I know inverses cancel each other out. So all I get is angle B. But whatever I got to do to one side, I got to do to the other. So this is what it's going to look like in our calculator. So when I typed into my calculator, here's what I got to do. On my phone, I got to do 8. I got to do divided by. I got to do 15. I got to do equals, and I'm going to get that decimal. And then you know where the inverse is located? You got to press the second button on your phone, and then press cosine -1. So when you do all that, you should get it's about 57.76 and a whole bunch. So if we're rounding to the nearest degree, let's say that angle B is 58 degrees. Nice. You tried. Let's give this one a shot. Find the measure of angle Q, round it to the nearest tenth. I'm sorry, nearest degree. All right. We start with our friend SOHCAHTOA. And let's think, if I'm finding angle Q, I'm finding this angle up here. The 4 is my opposite. 10 is my hypotenuse. So that's what I'm using. Ha, ha, ha. I'm using so. Sine is opposite and hypotenuse. So the sine of angle Q equals 4/10. Now, if you remember before, I did like the inverse cosine of both sides. So I could do the inverse sine of both sides, but we typically don't write that line. We just kind of go right to Q equals the inverse sine of 4/10. So again, on your phonulator, that's your phone's calculator. We're going to type 4. We're going to do divided by. We're going to do 10. We're going to press equals to get the decimal. It's 0.4. And then we're going to do second if you haven't done so already. And we're going to press sine inverse. And when you do all that, hopefully you get Q is 23.57 and a bunch. So that's going to round up to 24 degrees. So we did a lot of really good work with trigonometry here. This is definitely a video that you might want to watch again. Get some practice with some trig. Have some fun.